Okay, good afternoon, folks. Here is what we did in calc class today. I'll go ahead and share my screen. Sorry for a little bit of snipping. Okay, we went through some of those with rather. So what we did, we talked about limits from a graph. So again, the way we understand a limit from a graph, it's different than actually looking for the value of a function at a point. So what I mean is this: if I asked you what is the value at A, what is the value of this function at A? You would come right up here, you trace your finger over, and you'd say it's L. That is the value. But what we talked about today is we talked about this. What is the limit of my function f of x as x approaches A? So what I'm saying is the following. To do this limit, what we have to do is we have to trace it from the left and we have to trace it from the right. So what I mean is we have to see what happens when I come this way and what happens when I come this way. So in other words, writing it out, in order to figure this out, I have to do the limit of f of x as x approaches A from the left. I have to do the limit of f of x as x approaches A from the right. So what I'm going to do is I'm going to look and see as x approaches A from the left, I'm actually getting a value of L. As x approaches A from the right, so this way, I'm also approaching L. Notice these are both the same. Since they're both the same, we can say that the limit actually exists, and the limit is f of x as x approaches A is L. So what we're going to do is we are going to go ahead and we are going to keep working that. Just hold one moment. Okay, so we're going to go back and take a look at that. Share my screen. And now what we're going to do is we're going to look at an example we did from class. So let us take a look at this one right here with our letters. So the way we want to look at this, what is f of A? So what that means is when I go to A, I go up and I find this filled in dot. So f of A, the value of the function at A, in this case is M. It's where the closed circle is at M. However, when I look at the limit as x approaches A, what I need to do is I need to look at as it approaches it from the left and as it approaches A from the right. And as I approach A from the left, this is A from the left, right here, A from the left, I'm getting L. As I approach A from the right, and this is A from the right, I'm also getting L. Since these two are the same, the limit is L. Now what I'm going to do is I'm going to look at the limit as x approaches B. So again, I need to look at B from the left, and I need to look at B from the right. So what I'm going to do is I'm going to look at B from the left. And as I go ahead and I approach B from the left, this is B from the left, because I'm left of B, it's giving me an M. So as I approach B from the left, I get an M. As I approach B from the right, which is this way, this is B from the right, I'm getting K. So if you notice this M and K, not the same thing, that tells me that this limit does not exist. And I can follow the same process for C. As I come C from the left, so C from the left, I get L. As I go C from the right, I also get L. So that limit's L. As I approach D from the left, I'm getting J. As I approach D from the right, I'm also getting J. So the limit as x approaches D is J. And then the last one says what's happening of the limit as x approaches B from the left side. As x approaches B from the left side, I'm going up here and I'm actually getting M. So that's what we did with our limits from a graph. So we did a few of those examples in class. I just wanted you to see that. And then what we did is we talked about some of our limits that don't exist. This is a primary one we all deal with where it doesn't have the same behavior from the left and the right. From the left side, it comes to -1. From the right side, it comes to 1. So therefore, the limit doesn't exist. We will talk about unbounded behavior. It's kind of hard to see this, but what this is happening is when I look at 0, this guy is approaching infinity. Because if you think about it, this line just keeps getting closer and closer and closer to the x-axis, but it never touches it. Same with this one. Anytime an infinity is involved, we're talking about it does not exist. So positive infinities up here, negative infinity down at the bottom. And this doesn't happen very often in AB, but I wanted you to know about it. It's called oscillating behavior. It kind of jumps up and down like this. That's technically a limit that's not existing. So just so we're aware of that. And the last thing we did was limits from a table. So what you can do is you can plug this into the calculator and you can kind of get your numbers. And what you're going to find out is that this is like, I think it's 0.4, no, it's 39. It's 0.39. This is 0.039. This is 0.0039. This is negative 0.004. This is negative 0.04, and this is negative 0.4. And as you notice, as we are kind of working our way in, as we approach 2, these numbers are collapsing in on 0. So what that tells me that this limit is 0. So what you should just do is kind of see if those numbers are collapsing on something. The big deal you got to focus on is when these two numbers aren't collapsing on something. So for example, let's say I was coming from one direction and I got like from the left side of A, I saw that that thing was approaching negative 1,000. But as I went from the positive side of A, this thing was approaching positive 1,000. That's an unbounded behavior. So what that actually tells me is that there's no limit there that you have. It does not exist. So you'll be working with some tables. And again, some of these is just plugging. You're kind of seeing where the numbers are collapsing on. Again, as you notice, this goes from like a positive 0.4 to a negative 0.4. And as we get closer, it's like positive 0.04 to negative 0.04. Positive 0.004 to negative 0.004. And if we kept going, if we did 1.9999, it would be 0.0004 and negative 0.0004. And as you notice, it's condensing or collapsing, converging in on 0. So that's the other part we talked about. And then I told you what your homework was. So hopefully that helps. Please use the reflection to ask me questions if you have them. And get ready. We're going to do a little bit more on limits when we get back together on Friday.